Welcome to the section on Introduction to Fuel Cell Vehicles. In this section, we will explore the working principles and major components of fuel cell vehicles. So, what exactly is a fuel cell vehicle? Well, a fuel cell vehicle is an electric vehicle that uses fuel cell to generate electricity on board. Unlike traditional internal combustion vehicles that rely on fossil fuels, fuel cell vehicles utilize hydrogen as their primary fuel source. The use of hydrogen in fuel cell vehicles offers several advantages, including zero tailpipe emissions and a potential for sustainable energy future.
At the heart of a fuel cell vehicle is the fuel cell stack. This stack consists of multiple individual fuel cells that convert hydrogen and oxygen into electricity through an electrochemical reaction. The fuel cells are typically arranged in a series to achieve the desired power output. To initiate the reaction, hydrogen gas is fed into the anode side of the fuel cell, while oxygen or air is supplied to the cathode side. At the anode, the hydrogen molecules are split into positively charged protons and negatively charged electrons. The protons then pass through a proton exchange membrane, while the electrons travel through an external circuit, creating an electrical current. On the cathode side, oxygen molecules from the air combine with the electrons flowing through the external circuit and the protons diffusing through the membrane. This process generates water as a byproduct, which is expelled as harmless water vapor. The electricity produced by the fuel cell stack powers an electric motor, which drives the vehicle's wheels, providing propulsion. The electric motor operates similarly to those found in battery electric vehicles. It delivers instantaneous torque, resulting in smooth and quiet acceleration. Now let's take a closer look at the major components of a fuel cell vehicle. Apart from the fuel cell stack and electric motor, there are a few key components that contribute to the overall operation and efficiency of the vehicle. First, we have the hydrogen storage system. Hydrogen is stored in high-pressure tanks or in the form of metal hydrides, which have the ability to absorb and release hydrogen. These storage methods allow for the safe and efficient storage of hydrogen on board the vehicle. Another crucial component is the power control unit, which manages the flow of electricity between the fuel cell stack and the electric motor. The power control unit ensures that the power generated by the fuel cell stack is utilized efficiently and continuously supplies the necessary power to the electric motor. Additionally, fuel cell vehicles are equipped with a battery pack. This battery acts as a secondary energy storage system, providing additional power when needed, such as during acceleration or regenerative braking. The battery also helps to improve the overall efficiency of the vehicle by capturing and storing energy that would otherwise be lost. To complete the system, they also require various auxiliary components, including cooling systems to maintain the optimal operating temperature of the fuel cell stack, air filters to ensure clean oxygen supply, and compressors to pressurize the air and ensure effective fuel usage. In summary, fuel cell vehicles operate by using hydrogen as a fuel source in a fuel cell stack to generate electricity that powers an electric motor. Key components include the fuel cell stack, hydrogen storage system, power control unit, battery pack, and auxiliary components. The result is a clean and efficient vehicle that offers zero-emission mobility and the potential for a sustainable future. Learning about the working principles and major components of fuel cell vehicles is an important foundation for understanding the broader concepts and advancements in this rapidly evolving field.